In this lesson, we'll be covering simple trigonometric identities. So first, let's start out with what a trigonometric identity is. So a trigonometric identity is an expression involving any of the 6 trigonometric ratios that can be changed to another equivalent expression also involving any trigonometric ratios. So there are many identities out there, and they can be quite simple to very complicated to prove. Probably a more simple one that you would recognize is this one here. So you'll recall that cosecant is just the reciprocal of sine. So this here is an identity because cosecant can be changed into 1 over sine x. So both the left side and the right side are equivalent. So there are many identities, but here are the basic ones that you will need to use in order to prove the identities in this course. So you should hopefully recognize these 3 identities here. They are just your reciprocal identities. So 1 over sine is the same as cosecant, 1 over cosine is the same as secant, and 1 over tangent is the same as cotangent. These identities here are called your quotient identities, and these last 3 equations here are called your Pythagorean identities. So using the identities that we previously discussed, let's prove an example identity. So in this case, we have to prove this identity here. So to do that, we will have to use the identities we know to manipulate either the left or right side or both in order to show that they are in fact equivalent. There can be some complicated identities out there, so it may take you several tries in order to manipulate your equation to prove it's equal. So I will try to give you some basic strategies to help you along in trying to prove identities. So a good tip is that you usually want to manipulate the side that is more complicated. So in this case, it should be quite clear that the left side is more complicated than the right side. So it will be easier for us to manipulate the left side to try to get it equal to the right side as opposed to the other way around. So let's just work with the left side. So the left side is 1 over secant squared x plus 1 over cosecant squared x all over cosecant x times secant x. So now let's keep in mind that we want to manipulate this side of the equation to end up being sine x times cosine x. So we will try to take our reciprocal identities that you can see here and manipulate them to become primary trigonometric ratios. So let's first change 1 over secant squared x and 1 over cosecant squared x into their reciprocal identities. So 1 over secant squared x would become its reciprocal of cosine squared x. Cosecant squared x would become its reciprocal of sine squared x. As for the denominator, let's change cosecant x times secant x into their reciprocal as well. So now we will have a left side that is all our primary trigonometric ratios. So now that we have our left side with only primary trigonometric ratios and not the reciprocal ratios, we can start simplifying to try to make it look like the right side. So you should always be looking back at your identities that you're given to see if you can use those to simplify. So you'll notice that cosine squared x plus sine squared x here looks like this identity here. So we can simplify sine squared x plus cosine squared x to be 1, according to this identity. So let's rewrite the numerator as 1. And we'll combine what's in the denominator to be 1 over sine x times cosine x. So now it's just a matter of simplifying to finalize our answer. And if we simplify this, 1 divided by 1 over sine x times cos x would be sine x times cosine x. So in fact, we have proven that the left side of our identity is equal to the right side of our identity. So overall, we can use the identities that we know to be true to manipulate identities that we have to prove in order to show that the left side does equal the right side or to prove that it does not. And that concludes the lesson on simple trigonometric identities.